This is exponential functions part 2, and we're going to be graphing the equation y equals 4 times 2 to the power of x minus 3 plus 2. But in order to do that, we're first going to start by graphing the parent function y equals 4 times 2 to the x power. So I've picked some x values that I can plug in here to get some output values and some points that I can put on the graph. So if I plug in negative 2 as my exponent, negative 2, 2 to the negative second power will be 1/4 times 4 is 1. 2 to the negative first power is 1/2 times 4 is 2. 2 to the 0 power is 1 times 4 is 4. 2 to the first power is 2 times 4 is 8. And 2 to the second power is 4 times 4 is 16. So I can now plug these points in on my graph and connect them, and I'll have a graph of my parent function. So my graph is going to be getting close to the x-axis, but never quite touch. The fractions will get pretty small, but I'll never get down to 0. Now I want to graph my original equation, which was y equals 4 times 2 to the power of x minus 3 plus 2. Now this is going to be a translation of our parent function. This graph is going to be moved 3 units to the right and 2 units up. I know 3 units to the right because anything affecting my exponent is going to move my graph to the right or left. If I'm subtracting a number, I'm moving that number to the right. If I'm adding a number to my exponent, I'm moving that many to the left. Once I find my answer for this first part, if I'm adding a number to that answer, I'm going to be moving that many units up. If I'm subtracting a number here, I'll be moving that many numbers down. So in this case, I'm going 3 to the right and 2 up with each point. So every single point, I can move 3 to the right, up 2 spaces. 3 to the right, up 2 spaces. 3 to the right, and then up 2 spaces. 3 to the right, up 2 spaces. And 3 to the right, up 2 spaces. So since this graph went up 2 spaces, it's approaching but will never reach the line y equals 2. So in this case, for my domain, I have all real numbers. But when it comes to my range, the y values are all greater than 2. They're all above the line y equals 2. I can use a table to write an exponential function. My exponential functions are in the form y equals a times b to the x power. This value a is my y-intercept, because anything to the 0 power, when x is 0, it's going to give me 1. So it's going to be 1 times this number. And when x is 0, that's where we get our y-intercept. 0 comma anything is going to be our y-intercept. So when I want to write a function for the values in this table, the first thing I want to find is the y-intercept. That's my a value. Now the y is increasing in this case by a value of times 5, while my x values are going up by 1. That tells me that every time I go up a y value, it's increasing by 5, and the number of 5s it increases by depends on what value of x I have here. So this b value is how much my y values are being multiplied by when the x value is increasing by 1. So this table's values could be represented by the equation y equals 2 times 5 to the x power. We can use this in real life situations. Here we have a graph representing the bacterial population y after x days. And we have a bunch of different points here, which I've transferred into a table. So on the 0 day, we had 3 bacteria. On the first day, 12. The second day, 48. The third day, 192. And the fourth day, 768. So if I want to write an equation for this bacterial population, I first want to find my y-intercept, which is 3. And as my x values are increasing by 1, my y values are increasing by a value of times 4. So my equation for this data is y equals 3 times 4 to the x power. Now, if I want to estimate the population after 12 hours and 5 days, I can use my equation that I've written here. So 12 hours is half of a day, so I'm going to plug in for x 1/2. So 4 to the power of 1/2 is the same as doing the square root of 4, which is 2, so I'm doing 3 times 2. And the bacterial population after 12 hours is 6 bacteria. After 5 days, I'm going to plug in a value of 5 for x. 4 to the 5th power is going to give me 1,024. And 3 times 1,024 is going to give me 3,072. So after 5 days, we have a bacterial population of 3,072 bacteria.